Hello, ladies and gentlemen. We're going to take a look at Odin a bit more in depth. So what exactly we're going to take a look at is actually the memory allocations and the context system, basically. So if you don't know already, Odin has a thing called context. It's baked into the language itself, and it is using some shenanigans to make that work. What I mean by shenanigans is that Odin passes to the functions implicitly, and it's kind of a magic. Not real magic. There's obviously an explanation how that passes, how Odin passes the context into the functions implicitly, but um, it feels like a bit of magicy. It feels magicy. We can take a look at more in detail in this overview with the implicit context system. So it's actually not even, it's in each scope. I didn't even know that. It's actually inside of each scope. So you can probably change the behavior per scope. So that kind of makes more sense. But it kind of also makes it more magic-y, but anyway, today we're going to take a look at that. Exactly how this thing works. Let's create a basic program, I guess. Let's call it Odin Odin let's just call it context system. Context.odin. The top level name of this is basically just Odin context. Yeah. Because the context keyword is taken, we can't use that in here, I think. Yeah, we cannot use it. Okay. This is the main procedure. And let's have the FMT here. I'm just gonna call def, and it was in core, I think, right? I don't remember exactly. F prints ln hello world. Programming Odin. Yeah, Odin run context Odin file. Main is reserved as the entry point procedure in the initial scope. Oh, yeah, okay. But there we go. Okay, so that's that. We got a working Odin program. So this works. Okay. So in Odin, we can allocate memory by saying, I think it's new or something like that. There's a keyword for that. Where's the keyword? Okay. Let's try, let's see. Where's the keyword? What did the, oh my god, okay. I think it's new. Okay, it's not new, apparently. It is new. Okay, wait, why is it not highlighted? That's kind of bizarre, but that's alright. Okay, so we can allocate memory by using new. And we can just say, I don't know, let's create an integer, I guess, who, this is i32. It's a pointer. We tell it to be like this, and this is integer. I guess we don't need to put it like this to make it Yeah, it can infer that information. And then we can take a look at the fool's address, although I don't know how it's going to tell us that. Like what? Okay, it literally printed the address. That's great. So this seems all right. So it's a pointer. We can dereference it. Was it like this? Is used for pointer types. Okay. So do we dereference it like this or something? No. Okay. How do we dereference this thing? Pointer. Okay. So it's the other way. Oh my god. Okay. So it's like this. Okay. So we can dereference like that. It's zero initialized. That's fine. So can we just say this is 69 like this? Is it going to auto dereference or we have to dereference it ourselves? Okay, yeah, it's a video declaration. Okay, we have to dereference ourselves, which is fine. Okay, it works. So this is how we can allocate memory in Odin. But how does this new works? How does this work? I mean, where is the allocator? Where we can take a look at that with debugger. Let's say build, and I think there is a flag for debug information somewhere. Yeah, it's not enabled by default, I think. So we have to do it like this. This is build and debug. Okay, so there's context, and we will open our debugger. I'm going to be using NND. If you don't know, NND is a debugger for Linux written from scratch. It's written in Rust, but that doesn't really matter. It works really well. It's TUI, meaning it runs on the console. I think it works really well, and it's an alternative to GDB. Context, yeah, okay. Okay, not this one. Run to main. Let's run to main. Can we see? Okay, that's the thing. How do we open the files again? I kind of forgot. Okay, oh. Context Odin. Yeah, there you go. I'm going to put a breakpoint on here and just continue. Okay, there we go. So we have foo in here. Okay, so we can already see the context as a local in here. And we can see that there is an allocator assigned to it, which is coming from the Odin's own runtime. Can we inspect that? Can we just see that in here? Odin Linux. Core. Is it in? Maybe? No. Maybe it's in here. Yeah. We can take a look at that in base runtime. Here, I think. Base runtime allocator. Heap allocator Odin. So what is this? Heap allocator. It returns this. But is this heap allocator? Yeah, it seems to be a heap. Oh, we can open it here as well. Okay. So it does seem to be. We do seem to be looking at the right place here. So this is the heap allocator, and it's the implementation. We can take a look at that more in depth, but I don't think we need to do that too much. I guess we can just confirm if it is using malloc or just the syscalls directly. And how can we look at that? How does it allocate the memory? Heap alloc. Okay. There is this thing. Okay, so where does this thing come from? Okay, so this thing is intrinsic, I assume. Yeah, base intrinsics. So we don't really know what this function is. But we can hopefully take a look at that in here. I'm gonna put an entry point here and see if it's going to go down in there. But we can also go down into the new function here. It's actually a keyword, not a function, but yes. So it goes in, it's in the built-in thing in here called maybe. Okay, it's in this function. It is apparently a function, not a keyword. So that's actually a distinction. I didn't actually realize that. I thought it would be a keyword, and not. um. Okay, what does it say? The new built-in procedure allocates memory. It's a built-in procedure, so it's injected into our Odin programs always. I guess if you don't use it, it's going to be removed, but anyway. So this goes into a bit more. We can go a bit more, hopefully. It went into unknown. No line number, okay. Let's see. Okay, I don't think we're going to be able to see it. Yeah, it got returned out of it. So no, we're going to be able to see it because this thing calls runtime memalloc bytes. Let's see. Yeah, okay. We are in here. And this is going to be dispatching into the allocator procedure. And it is going to be, I think that's dynamic dispatch. Hold on. Keep allocator procedure. Is it? No, it's not a dynamic dispatch. And it's going to into align alloc, yeah, okay. And I think we are indeed going into the this function at some point. But let's see. Heap resize. Okay, heap alloc. Yeah, okay, there we go. So I don't think we can go any deeper than that because I didn't compile Odin with debug information. But let's try to go into a bit more anyway. And it wasn't an intrinsic. Okay, that's actually great. We do know it actually calls malloc on our system now. Yeah, and we can't go into that, but that's fine. Okay. So we got through that. Okay, hold on. Uh, default more core. What is this? Can I just get out of here? Well, I guess we don't really need to know more. Okay, don't need to know more. So let's see. So now we know how at least this new function works. And we know a bit more about context system. So the context is literally injected to our scopes. And we did see that in the debugger as well. So it's more or less an implicit variable that you don't set and you get it by default. But I think you can get it well, you can reject the context by saying this is contextless, I think. At least that's what I'm guessing, because I saw that this there's a way to change the ABI to contextless somewhere. Yeah, here. Okay, it's not, it's going to be in here actually. This is how you change the ABI, by the way, of the procedure or the function. In Odin, they call procedure because functions return something, but procedures may not, or something like that. I don't know. Anyway, it doesn't really matter to us. So if we run this, if we build it and run it, okay, we cannot build it because context has to be defined, and the main procedure cannot have a custom. Apparently, we can just say um, I guess your mom.
Bruh.
Your mom can be contextless then. I think that's all right. Yeah. You can just delegate this into here and call your mom here. And okay, context has not been defined within the scope, but is required for this procedure call. And they gave us a suggestion that we can set the context to runtime default context. Can I just set it to nil? Context nil. Cannot convert value to, okay. This has to be like this. And okay, so can I just say context here? Is that enough to define it? It's not. We can define our own context to make it zero initialized. I'm just gonna see, I want to see how it's gonna behave when the context is invalid. So how do we define that? My context, let's just call it like that. And can I just say this context like that? What is the type of the context? Or where does it even come from? I'm not quite sure. Okay, so is going to be context. My context. Context. Where does the context come from? Implicit context system. It's in package runtime. Okay. It's in package runtime. Import. It says package runtime, but is it like, okay, it's in base runtime. Base runtime and core. Core. Or is it in just runtime? Can I just say it like that? And let's see. It did build. Okay, that's great. Let's take a look at the NMD thing. Yeah. Let's take a look at it with debugger. Context. Okay, so it crashed, by the way. You can see the stack here. We don't really need to see that. Let's just put a breakpoint and run it again. I keep forgetting how to kill this thing. No, not. Okay. Run. There we go. So this is set in our context. By the way, this has to be 0 initialized. Yeah, okay, this is 0 initialized. So this is going to call our wait, okay, hold on. and it needs context. Okay, so that's not just setting a variable then. Wait. Huh. That's actually interesting. I didn't really... I kind of expected this thing to work as a normal variable, but apparently not. There are some private functions in the Odin itself, in Odin runtime, for context. It's setting the procedures. Oh, so if you don't... Oh, no. No, no, no. Okay, that's... No, that's different. Okay. Hmm. But why? Wait, okay. Do not initialize these procedures with a call as they're not defined. So that got out of in there. So is this different now? Yeah, they are different. Hold on. Wait. Okay, okay. They're not different. Okay. I forgot to step. So this is gonna go in here. And if we go a bit more, yeah, event a bit more, and it does call that, and that's going to crash it. Yeah, it's equals. Yeah, okay. So that's what we expect because it's touching basically nothing. It's touching the zero. We can create our own thingy in here, but so initializing the context, I guess context keyword, context intrinsic or something. I'm not quite sure, but it doesn't matter too much. But it is calling a function implicitly. This it's kind of bizarre that this thing calls a function just to set a variable, because this context thing, okay, is a normal Odin struct, so I don't know why it needs to call a function for that and do some other things. Anyway, we can create an allocator to see a bit more. Wait, what was that? Real dynamic? What the? Oh, raw dynamic array. Okay. Also, these are the things for the dynamic array. This is literally dynamic array struct for Odin, I guess. That's okay. Where's the allocator? Okay. Where is allocator? Okay, can I just go here then? It is in base runtime core allocator. Okay, it's in here. So it takes an allocator procedure and we can use this to create our own allocator. But honestly, that's not really interesting that much because yeah, it's not really that interesting, I think. We can remove this. Okay, let's take a look at dynamic arrays. So we saw a raw type here for dynamic array. Okay, so This is the dynamic array type in Odin, the actual type of dynamic things. Mhm. It also takes an allocator. And the fixed capacity dynamic array is a different one, which makes sense. There's also string type, a slice type as well. Uh-huh. Why slice is a different type? Is there a normal array here? Like, I don't think so. So how is an actual array defined then? Hmm. Because an actual array is also just a slice. I guess it may be just slice. That also makes sense as a type, I guess. So let's just say, mm, let's let's do a string, but that might not be a great idea. Let's do a dynamic array. Okay. Array. Let's just call it array, and it is dynamic of runes. I think rune is the character type for Odin. If I remember that correctly, that is. Let's see. Basic types. Rune. Sign 32 bits represents Unicode code point. Right. I guess that's alright. Or we can also do something else, but let's try rune. And I think there's a way to allocate this in here directly. I don't really remember it though. Dynamic arrays. Yeah, it's called make. You call make to do that. But let's not do that. Okay. Let's just make this integer. Okay. Rune is just gonna confuse me a bit. Uh, okay, let's call append. And this is array. And let's append 69. Okay. We can also then print this entire thing. I don't know if it's just gonna be able to print an array like that, but let's see. Let's try. And okay, let's build this. It built. Run it. Okay, so it can print arrays directly. That's great. Let's take a look at the assembly though. Why is this like that? Anyway, run it here. Okay. So we have, okay, so this array has data in it, len, capacity, and allocator set as fields. And that is literally this struct. Okay. Quite straightforward. Quite straightforward. All right. So there is context as well. Yeah. Let's go. Okay, so that didn't do anything because it just set to 0. Great. Let's go deeper into the append function. And it is apparently an overloaded function. All right. Go deeper than this. So appending an element. Appends an element to the end of a dynamic array. Okay. Hold on. I'm gonna. Okay. Yeah, there we go. So How does this thing work? It is taking an array, a generic pointer to an array. It has to be dynamic. There's a no broadcast thing, an attribute for arguments, and a location for debugging purposes, I guess. Num, it returns an integer and an error. Okay. How many things elements it appended, and if it's an error, it returns an error. All right. There is a check for compiler. There's a comp time check here, I think. I don't know when is actually a comp time thing, but there are uses for, I've seen usages of when for checking the operating system. So, and this is an append lm different function. Oh, so this is a built-in, core built-in thingy in the runtime. Okay. Okay, so this, it has an array capacity. If it has a capacity, it's just gonna, if it doesn't have a capacity, it's going to allocate memory. Yes, it's going to reserve dynamic array. You can go deeper to it. So this thing literally calls the allocator, checks for allocator first, then it calls it, yeah, then allocates some memory, and yeah, that's actually, it's just allocating memory. Okay, so then we're going to be in here. It is setting, yeah, it's going to copy the element in there, and that's really it. And it allocated 8 bytes for its first allocation. Yeah, that makes sense. Okay. Well, it's not 8 bytes. Pardon. It's 8 elements for integers, and that's not 8 bytes. It's actually, since integer is 64-bit in Odin, it is supposed to be 8 times 8. Right. And sometimes it goes into the println. You can also take a look at that. Can I? Okay. Let's take a look at that as well, because I'm also not sure how that thing works. So it has a flush argument as well, huh? So it literally, it always flushes if you don't say, if you don't explicitly set it to not flush. Okay. It's calling fprintln. It takes a file, which we're probably writing into a std out, standard output. So there is a buffered writer, and okay, initialization, writer to writer, writer to stream. All right. Why is this a different function though? I don't get it. Writer to stream. Okay, it literally convert. Okay. wprintln formats and writes to an IO writer using the default print settings. Yeah, okay. Write string. Fuck, I fucked it up. Okay. Bounce check error. Hold on. Where am I? I fucked it too much. Okay. Um. Oh, okay. That's FMT value. Write bytes. Let's go into that, I guess. It is calling write, and write is Is this libc right or its own right? I guess that's what we're going to see now. And we're going way too deep, okay. Partial switch mode, right, right to right, right to right, right to right writes to the contents of P into the buffer. Available copy. Oh, it's okay. So I'm not sure actually. It just wrote into a buffer. And where is that buffer coming from? Wprint learn. V. Uh, file. State writer. Uh-huh. Okay, that's the state. Okay, no fun. Oh, that's our data. Oh, so this is the, okay, this is the runtime generics in Odin, yeah. Use no termination false. Oh, that's W writer procedure. Okay, we did run into that. Huh. I'm not quite sure. Okay, let's take a look at it in here then. Core. Was it in here or something? I kind of don't remember. What is in OS specific thing? Run by still error right. Still error right. I'm just gonna guess and say it's going to be using this libc functions for this. Can we see? Can I see a write function? Okay. There is syswrite, OS specific syswrite. It may not actually be using the libc directly. Because there is a syscall for syswrite here. Is it used anywhere then? Hold on, my okay. Syswrite. It is used just somewhere, but this is old. Apparently, it says old here. So maybe it is not used. Does or it may be also, well, since this is coming from an import, it might make sense to say it like this. But why does it not work? No? Okay. Yeah, it doesn't matter anyway, I guess. Syswrite string. Syswrite. Maybe it's not like linux.syswrite. No. Sys. No, okay. We're not going to be finding it like that. Okay. Right. We can take a look at this, I guess. 94. Writer right. So this goes into the io.write. io.write. Core io. core IO Odin. And let's see if we can find the actual right procedure here. Okay, so it is calling this thing s.procedure, but that is coming from writer. But what is the writer in here? In here, the writer is B. Is this defined in here? Yeah, it is defined in here. So there is a buffer, an IO writer, core IO, Odin writer. It is a stream, and it has a stream procedure which is this thing. This awfully resembles the POSIX write function, but where not writer? Okay, 94. It's calling IO write. It's using the B writer. Let's go into this a bit more. All right, so running here, step inside. So I still not understanding where is the. Okay, let's run it again. Where is the. Oh, it's. Oh, wait, what is that? OS standard out. Oh, okay, that's what we're going to take a look at. Okay. It's a default. It has a default argument. I didn't see that. Okay. Not here. So OS, core OS, standard out, I guess, maybe. Core OS, file POSIX. We can maybe take a look at it. Grep. Standard out. Let's say core OS. Okay, we can also just do it like this. Core OS. So this is old. This standard out process POSIX. It is defined in format.js as 1 and os.standard out. There is a libc definition of standard out. It's setting here Linux, and there we go. We found it, I think, but that is old. That is old. We're not actually. Okay, maybe it's this one. Oops, I didn't copy it correctly. There's also this thing. Since we are on Linux, we're gonna take a look at this thing. It is procedure is this for standard out in Linux. And let's see. Okay, it's this private thing, and it is calling this function, and this function calls Linux write, and Linux write is it this thing or is it the syscall? Let's see. File count and size max RV. Yeah, this might be Linux write. Okay, Linux write is core sys Linux. Core sys Linux. Oops. Wait. Core sys Linux. Okay, which file is the Linux file here? Is it sys? How do I know that? It has to have the packaged Linux. Yeah, it is this, I think. It is calling this, right? Maybe. Um, yeah, it is calling the syscall directly. Great. It is using the syscall. It's not using the libc file, libc of the OS, which is great. Okay. Now we know how writing things work in Odin as well. Great. What else can we look at? Um, how long have I been streaming, by the way? 47 minutes. Okay. Uh, I'm just gonna refill my cup of tea and be back. Alright, so I am back. Let's see. What else can we look at? Bit sets, struct of arrays. Is this how does this work? How does this work? I guess we can take a look at this as well. Or we can try to modify the Odin compiler or something, but not quite sure which one would be more valuable. There is runner gzip. Okay. Maybe we can find something in the base here. Or we can take a look at the generic system. It's runtime generic, so that would be interesting. Um, we can see if it's defined in the runtime, or is it defined in the compiler itself. Let's see. Any type. Okay, that's not. Where can I see how generics work in here? Advanced types, generic, explicit parametric polymorphism. Yeah, this thingy. My new, yeah. There's a type ID, and it is dollar. This is probably a compiler thingy. We probably won't be able to see this thing. Let's take a look at base runtime. Let's see if we can see anything about generics. Grep. Base built-in. There's only one thing apparently in there. Oops, my keyboard. Okay. There's nothing in there. Well, there's something. Built-in Odin. So this is the built-in things. There's okay, it's just definition or some stuff. There's intrinsics and purely for documentation. Okay, great. Yeah, I don't think we can see that. Runtime. I don't see anything in here. We can take a look at dynamic array internals because surely it is using generics. No, actually, it's not using generics. Yeah, it's not using generics. Okay, that That's all right, I guess. That makes sense. There's always specific error checks. You can take a look at the entry for Linux or Unix entry. No CRT. There's different entries. No CRT. Let's take a look at no CRT entry. Oh, it is assembly. Okay, it's setting the stack and calling the Odin entry point. Okay, that's fine. That makes sense. Unix Odin. This is the CRT one. So it's try, it will do the libc main. It is it just calling this? Oh, it's dynamic thing. Okay. Yeah, it's calling this. Okay, that makes sense. So I don't think we're going to be able to find it, how any or generics work in this, or quite easily anyway. I mean, we can try to see it from the debugger maybe. Go in here. Does this use any generic stuff? No, I don't think so. Yeah, I don't think this uses any generics here. What is this? Type ID. We can try to do something and okay. We can try to get it like this, I guess. Let's just call this foo and print ln the type ID of this thing or some other information. Yeah, type ID of $T thing. And we can call foo here. Does this thing work though? Run. Oh, you have to put something. Yeah, okay. So we can do int here, I think. 69. Okay, we cannot do that. Bar int 69. Bar. There we go. Okay, hold on. Expect the type to assign type parameter. No, wait, what's happening here? Expected a type to assign to the type parameter. Oh, it requires a type because it has a type ID in there. Right. All right. Okay. That's not how we use this thing. We just can oh, I think I put any here. I'm supposed to put any at least. And let's not return anything. Uh, I have to do it like this. Type ID. Expect the type for type ID of. Yeah, okay. This is T. And this is type of T. Yeah, there is a type of. Just like this. Any. Right, that's not it. I don't think that's what I want. I don't. $T. Is it like this? $T is not a type. It's doing something in here with dollars. but it is only allowing a specialization of this table. Uh, Parametric polymorphism. Is this not a force inline? Must be compile immutable parameter. Compile time constants. Types can also be passed specifying like this. Okay. So can I just say this? No. This has to have a something in there. Bar expected constant value, and it has to be a constant if I do it like this, which is not what we want actually. I guess we do need to pass any, but any is not what we want. Can I just do it like in Zig, and this is type ID, and just say, okay, this is the T, which is T. Can I do something like that? T of redeclaration of T. Hold on. Parameter type T. Okay, yeah, okay. So this is type of bar then. So this expects. Oh, we can just print. Okay, we can just do type ID here. And this is supposed to be T. T is not a type. Type ID. Oh, it's like this. Okay. This is not a type. T is the type, not $T. Right. Oh, yeah, yeah. Okay, yeah, you're right. Okay, so this is the thing requires type ID of. So it doesn't return that part. Okay, yeah, finally. Thank you. So, okay, we can take a look at this in debugger now, I think. Build, debug, NND. Let's run into here, or we can do it here, I guess. Okay, so let's go into somewhere. It just directly went in here. Okay. Is there any way? Okay, can I just assign this to? I don't know. I guess we can just call bass for now, or bar again. Okay. Can I just, okay, I cannot go into the type ID of function. It's not even a function, apparently. What's going on? Okay. What is this? It's literally just one thing. It's basically an equal. So that's the thing in racks. So this is not a function. It's a constant then. Yeah, it's a constant. And that constant is probably something that compiler decides. So this is not runtime then. It's not runtime generics. I thought it had runtime generics though. Am I missing something? Did I misunderstood entire generics of Odin? Commonly, can't you just do? I don't know. The thing is, I'm not the Odin developer, so let's try that, I guess. Full well T. Well, dollar T. I think I tried this. I don't remember. Hold on. This is T, right? It may. Okay, hold on. This is just bar. Yeah, it can. You can do that. Yeah. Okay. Thank you. Uh, we can just call this well type ID, I guess, as well. Well type ID. Yeah. So does Odin have runtime generics? Because this is compile time. At least that's what I'm thinking here. Implicit parametric polymorphism. Is the runtime generics used with any keyword or something? Any. Go back. Yeah, any. Any type. And any type can be reference any data type. Don't think it has runtime generics. This is a very useful construct in order to have a runtime type safe printing procedure. Maybe I saw an interview of Ginger Bill somewhere that had I think he was talking about some cost for generics, and because of code explosion with compile time generics, he used some sort of a runtime generic stuff, but maybe that he was talking about this any type in here, not the parametric polymorphism thing in documented in here. Let's take a look at this any type. But how am I? Okay, it is relevant type ID. So we are supposed to be doing it like this then. Can I just put any here, and is that gonna work? Yeah, T is not type ID of val. Can I just put val? No, it needs to have explicit type. Can I just do type ID? That's not a function though, yeah. Cannot cast val as type ID from val. Any. Does any type have an ID which tells you the type? Yeah, that's what I'm gonna try to look at. Maybe type ID or type of. I think that was the function name. That did compile. Let's run it. It says it's any though. We kind of lost the information about its type though. It internally contains a pointer to the underlying data and its relevant type ID. Internally. We can call it debugger then and see what we have. Maybe. Maybe not. So bar, it literally calls this function and you only have val in here. The thing is, the valley has an ID here, right? Okay. And it did populate it. Its type ID is 15 apparently. Okay, how can I compare these things though? So val2, and this is $T. Let's call it something like this. 2, type ID of T. Yeah, it's missing. Okay, let's call bar again. Yeah, okay, it does build. So if I run this, it gives us two different results because which one is any one is generic, which is fine. Let's go in here. So val2 has only 69 inside. It's literally compile time generates. Okay. But this anything has a different stuff. It has, as it's said in here, it contains a pointer to the underlying data and its relevant type ID. So this type ID, I'm assuming, has to be equal to the $T or something. Proc val in switch. Val ID case int. Oh, so you can, yeah. Yeah, it makes sense so you can switch on them. Oh, so if I switch on them, I'm probably gonna see the same type ID or something. Maybe. Let's also put that in here. We are switching on val. Oh, you can just access the ID directly. Oh, okay. Okay, I see. Let's take a look at it. Okay, I think I understand it now. It's supposed to contain the same ID with the val this thing. Maybe. They're a bit different. Hold on. Okay, yeah, they are the same. If you take a look at the ID in the val here, its internal ID, it is the same thing here with the type ID of the integer. Yeah, we can print it like this then. We can say val.id here, and this is supposed to be the same ID, even though we can type ID. We can say val.id. Run. And yeah, okay. There we go. So any keyword gives us a runtime generics, I think, because it has a runtime type information in there. It's highly not recommended to use. Okay. So that's the generics of Odin, I guess. The type ID is defined by the compiler, so we don't really know how it works entirely. But it's just probably a unique ID. It's probably simple as that. I think this is it for Odin runtime. I mean, there's not runtime, but the things that hides from you. It doesn't really hide anything actually, because you can take a look at its own dynamic arrays type or its slice type directly from Odin, and it's literally Odin code, basic Odin code. Yeah, okay. I think that's going to be it today. I guess thank you for watching, and I will see you on the next one.